This is 12.2 for statistics doing a two-way ANOVA. This is question 2. Listed below are rating of pancakes made by experts. These are all the ratings. All these numbers are ratings. That means how good is a pancake. I don't know what is it. I think it's from 0 to 10 or 0 to 6. So it doesn't tell us what is the rating from 0 to something. But these are the rating, how good they taste. So different pancakes were made with and without supplement. So then we have supplement, and that means we put supplement means like vitamins and all these goodies in there, and then all the good stuff for your body. And then there's no supplement. And then with different amounts of V they have. So this one has no V. This is 10%, 20%, 30%. So what do you conclude? Use a 5% significant level. This is also a two-way ANOVA. Why this is a two-way ANOVA is because we got the rho factor. So don't forget, this is called a rho factor. Rho factor goes left, right. So the rho factor in this case is either you have supplement or no supplement. And then we have a column factors is the different amounts of V they use. So it's 0, 10, 20, and 30%. And these are the rating, which is the quantitative variable. So this is a two-way ANOVA because it has two categorical variables in this case. So, so how do you enter this into your notepad? So this is something that you will take some time to do it. So when you enter this from notepad, so I will use the VSA, WA, 0%. 10% I will use WB. 20% I will use WC. And 30% I will use WD. And then no supplement, I use NS, and supplement, I use S. So in this case, you should need to have 3 columns here. This is how we do two-way ANOVAs. You need 3. If you remember, you do 12.1, the two-way ANOVA, you just need 2 columns. But now you need 3 columns, and 2 of them has to be categorical, and 1 of them has to be quantitative. So how do you put the 4.4? 4.4 is WA for V. And to have supplement, you put NS because there's no supplement here, and the rating is 4.4. And then for the 4.5 rating, is the V is WA, and S is no supplement, and you got 4.5. And then same thing happens to 4.3, WA, NS, 4.3. And for this case, it's the WB because it's 10%, no supplement, and then you get a 4.6 rating. This one is also WB with 10% V, no supplement, and then 4.5. So you're going to enter all these things first for all the NS, and then the WA, WB, WC, WD, and then you do the same thing for the bottom row, where this is all going to be having supplement S. And don't forget, you need titles or context in this notepad here. And then you will have all this and the ratings all here. So then you save your file in this case. So this is, I know it's a bit more work, but then after that, your life is a little bit easy once you get this done. Okay. So once you get it done, we look at your requirements. So again, the first 2 requirements are robust. So assuming that we met it. This is not a simple random sample because this question did not say anything about simple random sample here. So we do not meet it. Independence, these are independent because each pancake mixed by different supplements and with or without supplements and the different types of wheat has a different rating. You doesn't know it because you rate differently, so they're all independent. It's a two-way ANOVA because we got 2 different factors, one with supplement or not, and then the other one is the different amount of wheat. And this is a balanced design. And why I say this is a balanced design, you find out that there are 3 belongs to this group, 3 belongs to this group, 3 belongs to that group, 3 belongs to that group, and then 3 belongs to the one that is supplement. So, and 3 and 3. So that means that every single one of these will have 3 each. So that's the reason why that is a balanced design. The sampling distribution here is F distribution. So, so once you save your notepad here, so what you do here now is you just go to mread table, and then after that you look at your M file name, and you find out they're all having the one that is coming out from your notepad here. And then now this will be easier. So you do not need to do like labeling your factor here. The reason why is because it's all been labeled to us. NS and S and WA, WB, WC, WD. So you do not need to do the label like what we did in the previous example where you had to put factor, sex, this one. The reason why is because here you already label nicely. If you do not label this, if you label this by 1, 2, 3, so that means that if your notepad is no longer like this, so you're gonna label this as 1, this is 1, this is 1, and then this is 2, this is 2, this is 2, and then the other one is a 3, and then you label all the NS is 1, and then you label all your S as 2 here. So if you do all like this, then you will have to go through this type of work where you have to label your factors here, that your V here has 3, 1, 2, 3 with the label of 4 factors with a label of WA, WB, WC, WD. And then the supplement here, you got 2 levels where you have NS and S, which is supplements or not. So that's the reason why that I would recommend you that do not use 1, 2, 3, 4 for your categorical variables, because once you label your categorical variables, this is you will have to do what we call as your labeling here. Okay, but once you label this, you just go through very easily. You just type because it's a label. So don't forget which one is row here. So row in this case is your supplement. So in this case, your sub is your row. Okay, don't forget. Your sub here is your row, and then this is your column. That means V is your column. So how do we do this? Is sub is your row. So we put AM sub and AMV and then XM rating, and then you do the summary AOV, and this is what you will get for your hypothesis testing. So we do a hypothesis testing here is the rating has no interaction between the pancake mix with without the supplements and with the different amounts of V. And then the now alternative hypothesis says there is an interaction. The rating has an interaction between the supplements that you put in and the different amounts of V. So when you look at this again, this is an interaction. So we will look at AB here, and you find out that your test statistic is 41.38 with a 0 plus, very small p-value. So this telling us that if your p-value is less than 0, less than alpha, in this case, alpha is 5%. Okay, so kind of close to 0 here. So 0 is less than 5%. So you can make a conclusion that a decision that we reject the null hypothesis. So there is sufficient evidence to warrant rejection of a claim that there is no interaction between the pancakes with or without supplement and with a different amounts of wheat. And you stop. The reason why you stop here is because you reclaim that there is an interaction. This means that if you do reject your null hypothesis, this telling us that there is you have an interaction here. So if you have an interaction, you do not need to continue to do row or column ones. So so this is very short actually. So once you do this, it's very short. So your final conclusion says that there is an interaction between if you put supplements or not and the different amounts of you put in. So that means both of them. So so you can also directly tell by looking at your p-value here, which is very small. So if this is very small, then you can tell these two also will be small, because we know that is an interaction between those two. So they all will come out really small p-value in this case. So so this is how we do question 12.2. So sometimes it is easy, so you only do one test like this. Sometimes it's hard where you have to do all 3 tests, and it all depends on the interaction test. So make sure you understand it. No interaction, you have to continue. And if you have an interaction, you will stop in this case. Okay, so there is an interaction here, so you will have to stop in this case. So these are very important stuff that you guys need to know, especially in this section 12.2.